Now, we talked about how to program the cavities for the jewelry applications. Now, the next thing we're going to go over is how you can actually machine the actual models itself, the ring models itself, using if you actually have the ring design itself and you wanted to see how you can effectively machine these ring models, and we can talk about that in the next example in here, where we'll talk about how to machine these parts, the actual models itself using indexed and continuous machining. Now, before I give you a quick demonstration of that, I would like to hand this back to Chris, so he would like to go over a couple of things in terms of how this can be efficiently programmed in our CAM system.
Before that, I just want to interject a little bit here. Another word on process. So what they just did or showed us was the master mold for maybe a wax model. So this is, you're creating an injection mold that you would create a wax model that we later take it to an investment casting process. So this is the first process that he showed. The process that we're going to show next is actually direct machining of a wax model. You might be able to do that if you don't have a lot of runs of that particular model. If you're doing a one-off or a specialized custom jewelry, you might want to actually directly machine the wax model. So that's what he's going to be showing. So we're not going to be showing, and that's the third application, obviously, which you can cut directly onto metal, gold or platinum, whatever metal you're using. You can use our methods to do that as well, but that's not what we're going to be showing next. So Chris, go ahead. Thank you.
Thank you, Joe. So before we proceed with the rest of the demonstration, we just wanted to quickly review the typical workflow that's used in this process of machining the ring models. So what you see in this slide is left to right a workflow where it's a three-step process for machining a ring model. So the ring is first laid flat and one side of the part is machined. And then the part is flipped over to machine the other side. And that's the picture that you see in the middle. Once these two operations are completed, it's followed by a rotary machining where the part is held vertically. So it's a typical three-step process. And in order to enable this workflow, there are some specialized fixtures. And what you see on this slide is fixtures that are used for flipping the part over, machining one side, flipping it over, and then machining the other side. And then once, as I mentioned earlier, once these operations are done, the next slide, there are some examples of rotary fixtures that are used for holding the part vertically in order to do the rotary machining. So we just wanted to take a moment to kind of walk through the workflow and the fixtures that are used. And now I'll hand it back to Uday.
Thank you, Krish. So as Krish pointed out, the workflow for machining the actual ring model itself, I'm going to go ahead and show you how we could take advantage of our toolpath methods in our CAM product to efficiently program, follow through this workflow in here. So I have the ring design that we just programmed a short while ago. We did the mold cavities for that. Now we'll actually look at how we can actually program this model in itself. So I actually have the ring, and also if you notice I have one of these fixtures in here for that ring right there. So what you look at in one of the presentation slides, here is a fixture for the ring. So you could be using your rotary axis and index it. You could be machining from the top, rotate it by 180 degrees and program it from the bottom. So in order to be able to machine it from two sides, we need to be able to make sure that the part is fixtured into the stock plank and doesn't fall apart when you're machining from two sides and then putting in a rotary. So we would need to prep the part or prepare it for machining in here. So what we're going to do is I'm going to use a fixture. Now if you take a look at this actual fixture in here, once it's machined on the top and the bottom, the part would get inserted over here on this tip for rotary machining. So that's the reason why I've created this fixture. So once you machine it from the top and bottom for the final finishing, you can line up this part that's finished from the two sides and then put it over to the tip for rotary machining. So we have designed a fixture with the holes that will line up for it. Now once I have this in place...
Right. I just want to interject one more time, sorry. The fixtures that Uday just showed, they're actually from a Roland machine. They come from a Roland JWX line, and we are using the models of those fixtures, so in case you're curious. Thank you.
Thank you, Joe. So you could be using your own fixtures that you may have designed, or you could come up with some standard fixtures you could, obtain. But in this particular example, we'll be using one of these fixture types. And once I have these, designed and placed in here, I'm also going to go ahead and create, some support structures to be able to hold on so that the part can remain intact with the stock material. So to create supports, I'm going to use some of the drawing tools in this CAD system in here. So I'll create a boundary in here so that we can contain our tool paths to an area. And also I'm going to add some support structures in here. So I'm going to use simple tools like creating a rectangle in here and extruding them to form supports. So I'm going to model these in here. You could use different types of support structures. I'll use some of the arraying tools in here. I'll do a transform array polar, and I'll basically create 4 of these items. And we now have created some supports in here. I can also go back and make some changes, modifications in here if I need to extend this, make it larger on one of these sides. So I can, you can use your creativity to create supports. It could be intricate, or it could be as simple as what I'm showing here. Now I'm also going to turn this into a solid extrusion by extruding it by solid models. I'm going to use some of the solid modeling tools in here, and we'll just extrude it to a thickness right there. Okay, so we now created the supports for the fixture and actually the part, so that the part stays intact when you machine it. Now the extent rectangle, what you see here is actually the extent of the fixture, the original fixture that we have to be able to play, the stock, so that it can sit inside the fixture right there. So that's what you're looking at. Now let's go ahead and build our stock material in here. So I'm going to click on copy model bounding box, and then I'll put in my material thickness, blank thickness as 16 millimeters. And in this step, next step, I'm going to align it. So use align it to have it centered and centered in X and Y. So we now define the stock and the part, and supports have been added to it. Now I would like to machine this in 2 halves, like using a flip machining. So I'm going to define my machine tool as 4-axis, and I'm going to use the rotary axis or axis of rotation as X in this particular machine, the Roland machine, the rotational axis is the X-axis, and typically also your rotary center and the origin is being left at the center, where the XYZ0 is right in the center of the part. So we've established that, so I'm going to select the post processor in here. I could pick a Roland, or I could pick any of the post processor. Now for this application, I'm going to use the Roland JWX30 as the post processor and output extension to NC. We're now ready to program our toolpaths. The workflow will be very similar to what we did earlier. So the first step is to create a roughing toolpath. So I'm going to use roughing in 3 axes. I'm going to select a containment. So I would like to contain the roughing toolpath to stay up to this inner rectangle in here. And for this particular process, I'm going to be using the 16th inch end mill for the roughing process. Establish the cutting parameters. In a cut levels, I'm going to set my bottom cut level to just slightly stay right up to the mid-plane, or I can go slightly below that by 0.1 millimeter, and then specify engage in retracts and any additional cut parameters, and then pick generate to generate the toolpath. So in this particular step, it's going to create a roughing toolpath. It does roughing in layers or roughing in levels, as you can see it. And now I'm going to go to the simulate tab to run a verification of it. You could always select pause and then pick simulate to end to run through the simulation of the roughing process. So once the roughing process is completed, I would want to go back and machine these holes to its through depth, so we don't have to program the holes from the other side. So I'm going to go to 2-axis, and I'm going to use a method called hole profiling to machine those holes. I'm going to pick the hole feature right in here, use the same tool, specify the cutting parameters. I'm going to put in the hole depth, and I'll put in the helix parameters for the hole, and then pick generate. So we now have a hole profiling toolpath for the center hole. It clears it out. I'm going to repeat the same step for the side holes in here as well. So make a copy of the operation, copy and paste it. So you could use Control-C, Control-V. So I'm going to use these holes. And with the same tool, in the cutting parameters, I'm going to choose at bottom. And the hole depth is going to be 3 millimeters and generate it. So the diameter or the size of the hole is automatically determined based on the arc or the circle that you selected in here. Finally, I'm going to repeat the same operation again for the through hole in here. Edit the operation. And I'm going to be selecting the curve edge regions. Again, reselect these edges from the hole and use the same set of parameters to generate it. So we now have a hole profiling for these 3 side holes as well. So once the roughing operation is completed, if you're working with a manual tool changer, you would want to minimize the tool change. So you could actually do the flip machining for the roughing on the other side as well. To do that, you would go to setup and add what is called a rotate table setup to flip the part over on your rotary axis. And then we're going to put in the table rotation as 180 degrees and then pick OK to accept it. So you'll now notice that the table rotary axis is turned over by 180 degrees on your machine, and you can repeat the same roughing operation in here. So I'm going to copy this over and then paste it under the rotate table setup so that now the operation is copied over, and I'm going to right click and regenerate. So now the roughing operation is being computed from the other side as well. So let's run a verification in here for the roughing. So you notice that the roughing on the side 1 is completed, so we are simulating the roughing operation for the flip side. You could always select pause and pick simulate to end to run through the simulation in here. So once the roughing operation is completed for both the sides, now it's been completed for the 2 sides, we would want to go back and add some finishing operations. So I'm going to switch back to the program tab in here. And the most commonly used type of finishing method in here would be like a radial machining operation in here. So I'm going to define a couple of boundaries in here. So I have 2 boundaries that are right on the edge of the part. So I'm going to offset these boundaries about a little over 1.5 millimeters from both the inner and the outer boundaries in here, so that we can have the cutter go past these edges to get a nice finish on it. So after the roughing operation is completed, I would want to go back and add a finishing operation. Now since we've already rotated to 180 degrees, we would want to go back and finish it from the bottom side first. I'm going to use a method called 3-axis radial machining. This operation is available in standard, expert, pro, and premium configurations. So to be able to do the flip side machining, you would need expert or higher configurations. The expert configurations allows you to do rotate table setups and also 4-axis continuous toolpaths. So we're going to be selecting these 2 boundaries in here for the radial machining operation. We'll pick the taper tool in here for the finishing process. We'll establish our cutting parameters for radial finishing. And I'm going to put the center point in here as 0, 0, 0. So that we're going to use a center point for establishing the radial machining toolpath. We'll specify a step over in here. And in the Z containment, I do not want to cut below 0.1 millimeter. So I'm going to establish that value right there. So I'm specifying in the parameters in here for the radial finishing. And in the clearance plane, I'm going to use a skim clearance for retracts. And then we'll pick generate. So in this particular step, we now have a radial finishing operation for the flip side, so the 180 degree side that we rotated from. So I'm going to switch to the simulate tab in here and run a verification for it. So there's the finishing operation for the flip side. So at any point of time, you could select pause and then pick simulate to end to run through the simulation. Now once the simulation has been completed on one of these sites, you would do the rotate table back to 0 and generate a finishing toolpath for the initial side, which was at 0 degrees, or the top half of the part. So I'm going to switch back to the Program tab, add a new rotate table setup, put the table angle back to 0. So now the part is being rotated back to its initial orientation. And I'm going to repeat the same radial machining operation, do a copy, and then do a paste. So now it's pasted under setup 3, and you see that the operation is flagged as dirty. So I'm going to right click and regenerate it so the toolpath is generated for the rotated orientation. And there's your simulation for the finishing operation from the two sides. So this is how typically you would be programming the flip side machining. Now once the machining from the two sides is completed, you would manually break off the tabs around the outside of the part. So the part would then be ready for tip machining or a rotary machining. So I'm going to let the simulation to run in here by selecting pause and simulate to end. While the simulation is being completed, I'm going to go ahead and show you how we could do the tip machining for the same part. Folks, we're going to be running over this just a few minutes, so hopefully that would be okay with you. So we can make sure that we cover the flip machining and the rotary machining for this ring model we were looking at. So we now have the ring model oriented, and we have the supports from the outside trimmed out, but the supports are still intact on the inside. And this is going to go into the fixture at the tip. As you notice the fixture, we showed this fixture during the flip side machining. So now you would be placing the in a ring with the fixture after machining from two sides over at the tip right over here. So this is how it's going to be, your setup would look like if you're using one of these fixture types. So it looks like the simulation would have been completed over here for the other side. So we have the program toolpaths programmed and simulated from the two sides. And then you can post-process by just going up to the machining job, right-click and post all will post both the setups, and it'll output the rotate table setups as well in your posted output file. So it has the output. So this output is for the Roland JWX30 machine. So I'm going to switch back to the rotary machining in here. So we now programmed the part from the two sides using flip machining or using rotate table setups, and now we are ready to program the 4-axis finishing toolpath on a rotary or a tip machining. So again, you define the machine tool as 4-axis, pick your configuration as table, establish your rotational axis and the rotation center in here, and then select your post processor that would be most appropriate for your machine tool in here. So I'm going to pick the JWX30 in here as well and use NC as the file extension. So to finish these sections, so you would want to finish these because when you machine it from two sides, it's going to leave material in here. So you want to result in a nice finish. So there's an overlap, even though you have an overlap, or you may have some additional features like prongs and other features on other ring designs, you would need to go back and do a rotary machining or a tip machining to produce a nice finish of the ring model itself. So to program this, we would be using a method called 4-axis and parallel finishing. So for this process, I'm going to be using the same taper tool that we used earlier, which is a 0.5 millimeter corner radius with a 2-degree taper. And we'll establish the feeds and speeds and clearance. So in this particular step, it's going to be a cylindrical clearance for a continuous 4-axis toolpath. In the cutting parameters, we would establish the global parameters, the stock to leave, and then you can choose your cut pattern. You can either go along the axis of rotation or you could go across. For this particular model, along would be more ideal. and you can specify your cut axial containment, which basically the length around which you want to cut on the x-axis. So in this particular case, it's automatically established this based off the low and the high values are established based off the actual part itself. If you need to extend it, you could always change these values, and you'll see that the preview, the planes on the graphic screens are displayed corresponding to the low and the high values in here. And we want to go 0 to 360, so we want to go around the entire model. So we want to leave the start angle at 0, end angle is 360, and we'll put in a step over in here. I'm going to use 15%. Now under step down, I could specify a radial cut level containment, like a bottom containment, and I'm going to specify this to be at about 8 millimeters. So I want to stop the cutter not going past 8 millimeters. I don't want it to go down to the fixture, so I'm going to put in a cut level radial containment of 8 millimeters in here, and then select generate to produce the toolpath. So there's the finishing toolpath, the parallel finishing 4-axis. We'll switch to the simulate tab and select play to run the verification. So this would result in the rotary or tip machining for the ring model that we just programmed. So you would do the flip machining first, and then remove the, break the supports away from the stock blank and place it over on the tip, and use the tip machining, the rotary machining to program around the ring. So with this, I would like to conclude the demonstration and hand this back to Krish.
Thank you, Uday. Thanks everyone for setting aside the hour to join us today. I know we went a little bit over, but hopefully this information was useful for everyone. Thank you for your questions as well. This webinar has been recorded, and you will receive an email as soon as it is uploaded for viewing. As always, we are available for questions during the week, so please call, email, Skype, or chat with us, and follow us on Twitter and Facebook, and please do keep in touch. Once again, thanks everybody.